Hello, everybody. How's everybody doing? I hope we're doing fine. And first things first, I want to notify everyone that remind everyone that we have the seventh Rational Physics Conference. And now we have a venue, we have a place. It's at Lars Kagsgatan, number 2. And that's in Bora, Sweden. We're going to have that on the 8th of June. Okay, so that's a month away. Make plans if you plan to come. Make your reservations. Okay, you're going to meet some interesting people if you go down there. Okay, let me know if there's a problem with the images or sound. I've been having problems lately. I think I know what's happened, but just in case, okay? Today I want to talk a little bit about a little dispute, a little skirmish that someone pointed out to me. There's going a little fight, a little struggle there between a philosopher of science, philosopher of physics, and an astrophysicist. And the philosopher is Mr. Bjorn Ekeberg. And he wrote a little article that was, to my surprise, really, it was published in the Scientific American. And here it is. Here's a little excerpt from there. Okay, it goes something like this. Okay, it says cosmology has some big problems. Oh my God, that's not a good way to start. An article that vouches for the establishment. And the first line is even worse. It says, what do we really know about our universe? Now, if that doesn't get you started, okay? And here's a couple excerpts from there. It says, in recent months, new measurements of the Hubble constant, the rate of universal expansion, suggested major differences between two independent methods of calculation. Discrepancies on the expansion rate have huge implications, not simply for calculation, but for the validity of cosmology's current standard model at the extreme scales of the cosmos. Oh. Another recent probe found galaxies inconsistent with the theory of dark matter. We discussed that last week, right? A little bit, okay? Which posits this hypothetical substance to be everywhere. But according to the latest measurements, it is not, suggesting the theory needs to be re-examined. Contrary to the scientific ideal of getting progressively closer to the truth, it looks rather like cosmology, to borrow a term from technology studies, has become path-dependent, overdetermined by the implications of its past inventions. Oh, those are mighty words, very dangerous words. You know, when Martin Luther rebelled against Rome, well, he had to run for his life, and I don't know. I feel for Dr. Bjorn. Well, he got a reply from someone in the establishment, obviously, who couldn't take it. And this man, his name is Ethan Siegel. He claims to be an astrophysicist. He said the following. Okay. And Mr. Siegel says, to point to a study, and again, just excerpts here, by the way, and the title is Cosmology's Only Big Problems Are Manufactured Misunderstandings. And he's going to address Dr. Bjorn. He says, to point to a steady crop of discrepancies is disingenuous, and I dare say deliberate. Misreading of the evidence used by Ekeberg to push forth a solipsistic, philosophically empty, anti-science agenda. Talk about a low blow. He didn't hold it back. A theory is only as good as verifiable predictions it can make. The key for any theory is to make robust predictions ahead of time, before the critical observation or measurement is performed. This way you can be certain you're testing your theory rather than tinkering with parameters after the fact. And he adds, there are now no viable alternatives to Big Bang. Okay, I'm glad that that's settled. Apparently, he's already made up his mind that Big Bang is the truth. Okay, and he says once you accept the Big Bang in a universe governed by general relativity, yeah, once you accept the Bible, you have to accept Jesus Christ, I guess, right? There is an enormous suite of evidence that points to the existence of dark matter and dark energy. Okay, notice he mentions the word evidence. Okay, dark energy's main competitor fell away some 15 years ago. Well, that's interesting. Okay, leaving only a universe with dark matter and dark energy as viable cosmology to explain the full suite of evidence. Okay, I'm worried about that word explain. Okay, keep that one in mind as well. So we got evidence and explain. But we mustn't forget or throw out the existing successes of general relativity, the expanding universe, the Big Bang, dark matter, dark energy, or inflation. Going beyond our current theories includes, as a mandatory requirement, encompassing and reproducing their triumphs. Until a robust alternative can reach that threshold, all pronouncements of big problems with the prevailing paradigm should be treated for what they are: ideologically driven diatribes without a requisite scientific merit to back them up. Oh man, looks like Dr. Bjorn really got stirred the beehive there. Well, what problems do I have with what Mr. Siegel is saying? Well, all I can recommend is Mr. Siegel take an introductory course in science. He obviously is not well versed in science or in physics, so I don't know how he can be an astrophysicist. But let's show where he's completely off the mark. He's not even wrong. That's the problem with Mr. Siegel. So let's go with what is science. Okay, first let's rehash that. And yeah, science has to do with rational explanations. We care about mechanisms. That's what in the context of physics. Okay, how do we do physics? We do it with objects. We don't do it with math. We don't have any use for mathematics or equations. We do it with objects. Why? Because we're going to explain a mechanism. You don't explain a mechanism with mathematics. You explain it by showing a movie of objects moving in there. Then you can understand the mechanism. And the invisible mechanisms we still have yet to understand are light, the workings of the atom, electricity, magnetism, and gravity. Of course, we have other phenomena such as black holes, dark matter, maybe the origin of the universe, if there is one. All these things have to be as well explained. But again, we're looking at mechanisms. That's what we need to find out. That's what science, that's what physics is about. So we don't need any math, because math can only describe. Math has no power to explain. And where do we put mathematical physics in its entirety? General relativity, quantum mechanics, string theory, atheism, agnosticism, all fall under religion. Why? Because they rely on belief, they rely on evidence, they rely on persuasion, persuading and convincing. We don't do that in science. In science, we are objective. We explain so that someone understands. And once that person understands, science is done with. We're done with it. What the person believes, what has been proven to him, what evidence he swallowed, that's his problem. That doesn't concern science. Science is only concerned about explaining a mechanism. You understand? We're done with science. What continues is religion. I have my religion, you have yours, everybody's got his own religion. And what these people are emphasizing are evidence. They're emphasizing experiment. They are emphasizing prediction. Okay, I'm going to make a little experiment here right in front of you, okay? And I'm going to include all these factors. I'm going to include observation. I'm going to include the experiment. Very expensive experiment, by the way. I'm going to exclude a prediction. We're going to have a mathematical description, and the question is whether I did science. Okay? Here's the experiment, okay? Watch carefully because this is very expensive, okay? I'm going to let the pen drop. I let go of it. It falls on my computer. Okay, and I'll do it to the side so that I don't touch any key. Okay, here it goes again. Okay, watch carefully. I let go of it, and it always falls to the ground. Now, I've done this experiment a million times, so it's a repeatable experiment, but you don't have to take my word for it. You can do it at home. Just take a pen, hold it, and just open your fingers and let it drop. And you'll notice that it'll fall downwards here on Earth, right? It'll fall to the floor, to the table, to whatever you have underneath you. Okay, you can repeat the experiment as many times as you want, unless there's some other factor like magnetism holding the metal pen up in the air. Well, that's a different story. But if it's free of any other influence, the pen will fall to the floor. It falls at 9.8 meters per second square, the acceleration of 9.8 meters per second square. It falls consistent with Newton's equation, mass times mass divided by distance squared. Okay? What else? It's an observation. It's a repeatable experiment. Have I done science? Have I done physics? And the answer is no. I can do an experiment every day of the year. In fact, we've been doing experiments on gravity for 400 years at least, since the days of Newton. No one can explain the mechanism of gravity. No one can explain the mechanism Mother Nature uses in her secret, invisible world of how that magic is done. And so we're not interested in the equations, in the description. We're not interested in observation. We're not interested in verifying anything. We don't verify anything in physics. We're interested in your explanation of the phenomena. How does Mother Nature do her magic? That's what we want to do. That's what we want to understand. And so when Mr. Siegel says that, you know, it's a done deal, this dark matter, dark energy, black holes, Big Bang, all the nonsense that comes out of mathematical physics today, yeah, you have to question that. You have to wonder whether they're doing science, let alone physics. Okay? And, you know, I showed a couple days ago that you have to make the invisible visible. Okay? And here's the example. You got Felix, okay? And he's going to break the window. And the question is, how did he break that window? From a distance. And did he use magic? Well, obviously, if you see this, you say, well, I gotta find out what he used. Obviously, you know, if you're going to rationalize this, you're going to say he threw something through that window. And then you got to figure out, you know, mentally what could be, you know, what he used to break that window. And of course, when you go see the true film, you'll see how he did it, okay? And here it is. Ah, now you see it. It was a horseshoe. He threw a horseshoe through the window. See, all you had to do was make the invisible visible. As long as you didn't see the horseshoe, it was magic. And, you know, if you saw this, you would say, well, how did he do this? Did he do it by action at a distance? Did he use magic? Did he say abracadabra and just wave his hand? You know, you wouldn't be able to figure it out. The only way you're going to figure it out if you mentally put something in there. This is physics. Physics has to be done with objects. Okay, you can only explain these mechanisms with objects. Here's another one just in case. And again, you see farmer pull on a donkey from far away. It's dark. You can't see very well. You're saying, well, how is he pulling the donkey in? You see the donkey going towards him. Well, you got to put something in there. Quantum mechanics puts particles and waves, and we're going to do it with a rope. Okay? Quantum mechanics says that you can throw particles at the donkey and draw them in. For sure, that's how they do gluons. Quarks are pulled towards each other by throwing gluons at each other. And of course, when you go look it up, you'll see that the gluon is illustrated as a bed spring. So it's more like what I'm proposing, the rope. Okay. Anyways, transverse waves, particles, they're one-wave mechanism. They're outward going. You cannot pull with either one. The only way you can do this is with some elongated object such as a rope. Okay. Okay. So science, rational explanations. You say, well, what is rational? Rational is your opinion. Sounds a fair attack, right? Well, no, because if you say something is good, something is bad, something is beautiful, something is ugly, that's your opinion. Okay? To the cockroach, her baby is the most beautiful in the world. Okay? That's simply the way it is, right? Okay? Everybody's got his own opinion. And in the case of rationality, we don't use opinions. We have a definition for it. We define irrational, especially. I like to define it in the negative, in the what is not rational, okay? And here it is. If you use a concept as an object, you have an irrational theory for the purposes of physics. You cannot say love moves mountains. Love is not a physical object for the purposes of physics, and you cannot say that the mechanism that you're going to propose is that love moves mountains. And of course, all of mathematical physics dies at number one there. Energy cannot be transferred, a mass cannot be moved, because all these are concepts. You cannot carry a force or an interaction. You cannot transmit information. There's no such physical object called information, and so on and so forth. And there are other factors to define irrationality. In other words, these are different criteria for irrational, using undefined words or using them inconsistently. The theory doesn't follow from the assumptions, okay? For example, I always give the example of the case where a lawyer or a detective, I guess, tries to explain a crime. Really, it'd be like the prosecutor. And the prosecutor tells the jury, he presents a knife as exhibit 1, exhibit A or exhibit 1. Puts it on there and says, the knife. And then he explains the theory with poison. It doesn't follow. Okay, so the theory has to follow from the elements that you present, what I call the initial scene. The initial scene is what you're going to use as a foundation for your theory. Okay, the theory has to be founded or based on the initial scene, on the assumptions that you make. Okay, and so what were some of the problems I found? See, in the case of Mr. Bjorn Ekeberg, what caught my attention is the fact that he put in his report, he made mention of a fellow which I had a one-liner. I only had a one-liner from this gentleman. And his name is Michael Disney, and he's a physicist. And Mr. Disney, number 2 there in the group, said the following: but the electromagnetic theory is not based on action at a distance, as was Newton's. Space is thought as being threaded throughout with electrical and magnetic tensions. And you will see other statements along those same lines. You have Mr. Ebbing, who wrote General Chemistry. A chemical bond acts like a stiff spring connecting nuclei. As a result, the nuclei in a molecule vibrate rather than maintain fixed positions relative to each other. And you see a picture of that on the right there. All the atoms are interconnected as if they were connected physically by a bed spring. Okay? And Casimir effect, if you look it up, a field in physics may be envisioned as if space were filled with interconnected vibrating balls and springs. Another representation, group in Colorado in the year 2000, Wiggling one charge causes the field lines attached to it to wiggle, and after a time, the other charge starts to wiggle. It's just like a rope connecting two rocks. The wave here consists of a wiggling line of electric force, which you can think of as being attached, quotation there, right, to the vibrating charge. And on the lower right, you see what is known as the hydrogen bond. That's water. The red is the oxygen. The gray ones there, the white gray ones, those are the hydrogen. And the little green things that you see there, those little lines, which are not very clearly defined or identified, those are supposedly what is known as hydrogen bonds. And you'll find this representation, the one that I found there, that comes in handy right here. And it says the following. It says, though hydrogen bonds are ubiquitous in almost every aspect of life, the exact nature of the interactions is still somewhat a mystery. We're talking about 100 years here, okay? It has been a topic of much controversy over the last century, okay, there it is, with a range of opinions from scientists across the world. They have no idea what a hydrogen bond is. And so I took the liberty of replacing the hydrogen bond with spirits and angels there on your right. Is that fair enough? I mean, if we can put anything in there and it doesn't matter what the physical interpretation is, I guess I'm allowed to put spirits and angels, right? Is that a hydrogen bond? I can put anything I want in there? And so you see what the problem is. The problem is that mathematical physics doesn't do physics with objects. They want to do physics with math, with equations. An equation can only describe. An equation cannot show me the mechanism, how a car works. I cannot tell you how a car works, the mechanism, by putting a bunch of equations there, or using words such as energy, undefined word, by the way, energy or mass, force, time. I have no use for those words, not in physics. Physics, you got to explain the mechanism. We need to understand what gravity is, how gravity is carried out, how Mother Nature does this magic trick. We still don't know. And the worst part is they've given up on this. Mathematical physics are not even interested in researching that subject anymore. It's covered. It's been taken care of. And the answer is, we don't know, we don't care, we'll never find out because the human mind is not capable of understanding the mechanism. Okay? Well, that's what I want to show today. I want to show that, at least in the case of what we were discussing, black holes, dark matter, we have a different explanation. We have a rational explanation. We have an explanation that you can visualize with your own eyes. You don't have to take my word for it. Just look at it. Whether you believe in it or not, that's a separate issue. I'm just going to show you a mechanism that you can see, you can understand, say, okay, I understand what Bill's got going through his mind. That's all I want you to understand today. You can have a million questions, you can believe or not, that's a separate issue. But I'm going to show you a mechanism. And that's what I think physics is. We need to figure out how Mother Nature does her secret, invisible stuff. And in the case of dark matter and black holes, I think we have a pretty good explanation for it. It's a mechanism that everybody can see and touch and visualize and whatever, okay? So you don't have to take my word for it. I could even keep my mouth shut, just show you the movie, and you say, okay, I understand the mechanism, okay? Now, whether you believe it or not, again, that's your problem. That's your biases, the way you were born, the way you were educated, whatever, okay? Okay, so we start where? Well, we start with what is light. First, I need to show you the mechanism, really the entity that underlies light. Okay, how are we going to explain light? We're going to explain light with a rope. We're saying that we have the torsion going along a rope. Torsion travels at very fast. Just don't take my word for it. Just go home, tie a rope to very tightly against two poles, two walls, whatever, and torque it. You put two clothespins at either end, move one, the other one moves instantaneously. That's how fast the torsion wave is. So what I'm saying here is that light is a torsion propagating along a rope, okay? And of course this explains also why the velocity of light not only is fast, but why it's a function of frequency times wavelength. If you make each one of those links that you see there, if you make them longer, you have fewer links. So for the same amount of rope, if you untorque it, you will find that the links get longer and you have fewer links. And if you torque it, and if you keep torquing it, the same amount of rope will give you more links, and each link will be smaller. And there you have C, little c, 300,000 kilometers, equals frequency times wavelength, which is the equation that comes out of Maxwell's equations. Okay, that's light. What does our atom look like? Well, the atom looks something like this. Let's see if I can get it in there. Okay. Wait till it starts here, but essentially what we have is two threads. To keep with convention, we'll call them electric and magnetic. The magnetic thread curves around and encapsulates the electric thread. The electric and magnetic threads from every atom in the universe, they fork out at the electron shell and they form this little star in the center. Okay? And here you see a better picture of it. And essentially what you see is the ropes end at the electron shell, which is the red line going around, and encapsulate the proton star that is trapped in the center. That's the hydrogen atom according to the rope model of light. And what this atom is going to do, it's going to pump, it's going to expand and contract and torque the rope. The torsion along the rope goes to another atom, and that's the sense that we receive in our eye. That's what we're going to call light or electromagnetism. Okay? Electricity and magnetism, same model here. We have a row of atoms. They swing one thread around. They really spin two threads around. What it does is, in fact, I can show it here. Let me show it to you for a second because I have corrected that over time. Here's my famous rope. Okay. And what it does is this thing spins so fast because the atoms that are attached to it, they're spinning very fast. And when they do, they open up the threads. So the threads start spinning around, okay? And that's going to be the magnetic field. It's gazillions of threads just spinning around the atoms. So you have a row of atoms and the threads spinning around. The electricity will move in this direction and the magnetic field is at 90 degrees. It can't be in any other way. And at least with this, we can mimic what Mr. Faraday and Mr. Maxwell had in mind, okay? And again, you're not supposed to believe this. You're supposed to only understand it, okay? People get confused between belief and understanding, okay? So let me put that back up again. Here it is. Let's see if we can see it. We have a row of atoms. We'll call them a serpentine. It swings the threads around. Electricity is into your eye, and as you can see, the threads can only go at 90 degrees to the flow of electric current. Okay, so that's the model for electricity. And you might say, okay, how does this produce magnetism? Here I have two magnets. Okay, okay. And we got to explain that magic. This is the entire system. Do we need math? Do we need calculus to explain this? Do we need to go to college to explain this to a 10-year-old? The answer is no. The answer is there's something, whatever it is, some invisible thing here, just like you saw a minute ago with Felix throwing the stone through the window, very similar. Right now we can't see what's in there, so you have to mentally put an image there. Tell me what is in there that produces this effect. What is the mechanism? Okay, so you got to explain this. Okay, and how do we explain it? Well, let's see if I can find it here. Give me a second here. There it is. Okay, we have the threads being swung around by those little rows of atoms that you see there. The top part of a magnet goes in the opposite direction of the bottom half of a magnet. You turn it around, nothing changes. It's only when you turn it at 180 degrees that you have repulsion. Okay, why? Because now you have both sides clockwise against counterclockwise. And when they're both facing clockwise, the two upper sides, the top sides, okay, the upper part of the magnet, then you can see that the top part draws on the top part and the bottom part draws or latches onto the bottom part, the threads. The threads are swinging around and latching onto the ones of the other magnet. As they get closer, more threads intervene, and as more threads intervene, you have an acceleration of the attraction. Okay? So that's the mechanism. You can see that nothing changes when you rotate it in that direction from top to bottom, but when you rotate it 180 degrees, you have push. They're pushing now. They're clashing against each other. So that's an explanation of a simple magnet. And again, we do this all with threads, with ropes. The only way you can explain action at a distance, as far as I'm concerned, is with some elongated object. You can't do it with particles. You can't do it with waves, transverse waves, longitudinal waves. You can't do it. You need to have some physical medium in there. Otherwise, you're introducing spirits in that same space, like I did a minute ago when I showed you the spirits holding, the hydrogen atom to the oxygen atom. In other words, for the water molecule, the hydrogen bond. Okay. Okay. Let me get this here. What's next? Just in case, I just want to rub it in. Magnets, you pour iron filings over a magnet on your table, and you'll see that they're all just lined up, right? And you say, well, yeah, looks like the field is static. That's not the case. As Maxwell said, there is matter in motion in that region. And here we show that Mr. Maxwell is absolutely right. Here we have a magnet underwater, and it's pulling one iron filing at a time. Something is in motion in there. And that's called the magnetic field, and that magnetic field is drawing one at a time. It's not like, when you put it on your desk, all the iron filings suddenly, in 1 second, just boom, just cover the magnet. No, here you can see that it's pulling one of them at a time. So yeah, there is something in motion. That's what a magnetic field is, and I'm saying it's the spinning of threads. It's the swinging of threads. It's pulling one iron filing at a time. Okay, and it's also magnetizing it. By the way, if you take one of those little iron filings later on, it has its domains aligned. Okay, okay, so gravity, last one, because we only need to explain really 5 major ones that we're aware of that are invisible to us. We have the workings of the atom. We have light. We have magnetism, we have electricity, and we have gravity. And here's gravity, okay? If I can find it, here it is. Here's a summary for gravity. Okay, all atoms are interconnected. Okay, that's the hypothesis, that's the proposal. They're all interconnected by electromagnetic ropes, as you see below on the left-hand side. 2 atoms, any 2 hydrogen atoms are interconnected by the electromagnetic rope. Electromagnetic only to keep with the words used in convention, right? Torsion along the rope is what we call light. And how do we explain gravity? Well, consistent with Newton's equation, the farther 2 objects are from each other, we have mass times mass divided by distance square. What are we talking about? We're talking about the number of ropes, of independent ropes. In other words, we're talking about how many ropes are pulling independently or acting independently. As the object, in this case the cylinder, approaches the cube, you can see that the same atom, number 6, suddenly is not aligned with 1, 2, 3, 4, and 5. Now they're all misaligned. They're all tugging individually. And the closer the cylinder approaches the cube, what you will find is what you see on the bottom. When they're farther apart, gravity is weak because all the threads, all the ropes act as a single coaxial. As you get them closer and closer, all the ropes fan out, and the objects are pulled towards each other faster and faster and faster, according to mass times mass divided by distance squared. Okay, so we have an explanation for Newton's equation with this, and it's all done with ropes. Just to rub it in one more time here, we have Mr. Richard Muller. He's from Berkeley, and he tells us the following. So, for example, if you have the Earth, there's a big mass here, and you have you with your little mass here. And you see the drawing on the blackboard. He's got a little man on top of the Earth, the big mass and the little mass, okay? And he's saying that every atom on Earth is pulling on every atom of you, right through other atoms. So the wall that you're in right now, you know, the room you're in now, the walls, every atom on the wall is pulling on you. Not only the one on the surface, but also the ones inside. They're pulling right through the other ones. Keep that in mind. And he says, you're also pulling on it. The amazing thing about gravity is that it goes right through things. Now, the only way you can explain this is, again, with some kind of elongated object that binds any two atoms in the universe. How else are you going to explain that the atom that's in the middle of the wall is pulling on you through the other atoms? Except, as I just showed here, where is it? I think it's this one. Unless you do it this way, the way you see it in the upper right, where every atom is connected to number 6, and the only difference is the position, the location of the two objects vis-a-vis each other. Okay? Then you can explain it, because they have to be connected. Otherwise, you're putting a spirit in there. You're saying somehow by magic, because there's some spirit, some witchcraft, the atoms are, the objects are coming together. Okay, so this is the issue. You have to put a physical object in there. That's what mathematical physics will never do. Will never do, because all they're interested in is doing equations, describing. They're not explaining mechanisms. That's why they don't do physics. The mathematical physics, the physics part is extra verbiage. Okay? Okay, so here's a picture of the Earth. I can see it here. Where is it? There it is. Of how the Earth is, every atom on the that comprises the Moon is tied to every atom comprising the Earth, and that they'll tell you why the Moon doesn't go flying out of the solar system, or the Earth also, you know, why it doesn't go flying out of the sun. And what I like to always show is a little picture here. And again, the one on the left shows that we don't know why the Earth doesn't fly away, and the one on the right tells you why it doesn't. It doesn't fly away because every atom on Earth is connected, physically connected to every atom comprising the sun. Okay? So that's the theory based on the rope hypothesis. Okay? Okay, so what do we want to explain? Well, we want to explain black holes and dark matter with all this. How does that fit in? Well, this is what we have to explain. 1972, it was Mr. Tom Bolton supposedly discovered that Cygnus X1 is a black hole. It was blessed by every mathematician, and this is more or less what he had in mind. He saw a star revolving around nothing. We have to explain this phenomenon, okay? Because this is, I have to believe it. I mean, I've never seen it myself, but I have no problem with this. I trust that this is what they saw, okay, the astronomers. They saw a star revolving around nothing. If this is the case, we have to explain it, okay? You know, it's like I showed a minute ago. If the window breaks, you got to explain how the window broke. You can't just say that Felix did abracadabra and waved his hand and the window broke. No, there's got to be a physical mechanism for this phenomenon, okay? What else do we have to explain? Well, here's another one. Where is it? Well, no, let me explain this one first, okay? We have a star moving around nothing, right? We have to explain this, right? Okay, so how do we explain it? Where is it? I can't find it. Oh, here it is. And we have an explanation for it. Here on Earth, we can run this experiment. You can run it in a lab. If you put a charged particle and you put it in a magnetic field, the charged particle will spiral, will go around in circles in that magnetic field. Is there a black hole in there in the center somewhere in there? No, of course not. You can do this with a magnetic field. And that's what's happening to a star that revolves around nothing. And here it is. Here's the magnetic field of a galaxy according to the rope model. What we have is on the bottom right, you see what I just showed. You see the little charged particle going around in circles. And then in there you see what I showed a minute ago with Tom Bolton's Cygnus X1. It's a little star that's going around in circles. Why? Because the magnetic field of the entire galaxy is sweeping down upon it and compelling it to move around in circles. That's the theory. Okay, we did it with magnetic threads. We don't use mass to mimic this. We don't have any use for mass at all. In fact, mass is a concept. We cannot say that mass does this. You have to produce the mechanism. You can't do it mathematically. You have to produce the physical object that is going to mediate this phenomenon. Okay, what's another problem that we have to solve? Well, here's another one. And again, these are illustrations that you'll find out there, but they're not the real thing, but you get the idea. We find that gases are sucked into nothing. And what they do is they put a black hole in there and they say, oh, they're sucked into a black hole. Or they fall. Some people don't like the word suck. They say, well, it's not like a vacuum cleaner. But the point is that gases fall into a black hole for some reason, right? And we have to explain this phenomenon. If gases of the skin of a star disappears into nothingness, we have to explain that phenomenon. So how do we explain it? Okay, well, here we have a little experiment that we do here on Earth. Here it is. And you can see smoke being drawn by a magnetic field, a rotating magnetic field. It just draws this gas. It's a gas because what is a gas? Gas is molecules floating in air, and that's what you see there. These are smoke is a bunch of particles. That's all it is, a bunch of molecules. And the point is, it's floating in air, and the magnetic field is drawing the smoke inwards. It's just pulling it and making it disappear into nothingness. Okay, so if we apply this to our galaxy, we see what's happening here. Let's see if we can get it in there. Again, on the lower right, you see what you just saw. The gas is being sucked in, or the smoke being sucked in by a rotating magnetic field. And that's exactly what we see in a galaxy. You see that gases can be sucked into nothingness, not because there's a black hole there, but because the magnetic field of the galaxy, which is a rotating magnetic field, is drawing them in and making them disappear, dissolving them, essentially. Not dissolving them in the sense that turns them into nothing, obviously, but it has a way of pulling the skin of a star, just like it has the power to make it rotate. So we don't need any mass to explain this. We do have mechanisms that we can do in a lab here that can show this same phenomenon from a different perspective. Should you believe me? No, you're supposed to understand me. The conclusions you reach are your personal business, and we don't even want to hear them in science. Take them to Sunday school. We just want to show you that there is a different mechanism to explain the same phenomenon with which the mathematicians struggle. Okay, what else? Well, we have also the dark matter issue. What do we have to explain about dark matter? Well, what we got to explain is a little graph, okay? And this graph shows that the farther a star is from the center of a galaxy, the faster it tends to go to keep up with those on the inside, okay? And the way they do it, they put a bunch of kilograms in there. They fill the space on the outer side of a galaxy with invisible kilograms. It's the dark kilogram theory, okay? Some people call it dark matter, but I like dark kilogram. And the main reason I like kilogram is, have you ever seen a kilogram? No, I guess not. Kilograms are invisible. You see the elephant, but you don't see his kilograms. And what they do is they get rid of the elephant and they say, look, there's a bunch of kilograms out there. And see, our equations now can describe it perfectly. Yeah, of course, if you put kilograms in an equation, you can explain anything with that. The question is, are there such things as those kilograms out there? And they say, well, yeah, they're out there, but see, we can't see them because they're invisible. They're dark matter, invisible matter, translucent matter, whatever you want to call it. So these guys are chasing spirits. And under the rope model, this has a very simple solution. Again, you don't have to believe the rope model. You're supposed to understand it, okay? And here it is. Very simple explanation for this phenomenon. And that's you have a spider web. Every star is interconnected. We put the spider web on top of the galaxy to simulate that all stars are interconnected. And now you can see why a galaxy rotates as a wheel, as a bicycle wheel. You know, the spokes, the hub, the rubber wheel, everything rotates at the same time. This rotates like a carousel, like a merry-go-round, okay? And that's because all stars are interconnected. This also explains why the stars don't go flying out of the galaxy, especially the ones on the outer edge of the galaxy. So we don't need any mass to explain this, okay? All we need is a physical mechanism, and I'm saying that all atoms are interconnected, and therefore all stars are also interconnected. Okay, so that in general terms gives you an idea what the rope model proposes for these phenomena. What we're saying here is essentially that there is a different explanation. There's a physical interpretation. There's a mechanism that you can see, you can analyze in a rational manner, and you can also criticize, obviously. You know, but in the case of mathematical physics, what are you going to criticize if they don't have a mechanism? They just tell you, they just give you a description. They say, look, if we ramp up the energy, if we ramp up the mass, if we lower the time, yeah, those are mathematical descriptions. You still don't have a mechanism how the car runs. You know, I'm not going to explain to you how a car works, how an engine works by telling you, you know, it runs at 50 kilometers per hour. What have I said? You know, I still don't know what the mechanism, how the wheels turn. And that's what's missing. What's missing is an analysis of what the mechanism is for all these things, how the universe works. I thought that was the purpose of physics, that we were trying to figure out how the universe works. And these people are not telling you how it works. They're describing mathematically with units and concepts that humans defined. I'm sure if you find Mother Nature tomorrow, or God himself, right? And you say, look, let me tell you how the universe works. And you begin telling him, God, you know, and say, the way a universe works is you have all this energy, and you have this mass, and you have this time. They're not going to understand what you're talking about. The only way you're going to explain the mechanism of how the universe works is with objects. And if you don't put objects, you're putting spirits. You're doing witchcraft. You're doing magic. You're doing abracadabra, okay? Moving your magic wand. So that's the problem we have with what Siegel here says. Where is he? Let's see if I can find him now. I lost him. Down at the bottom somewhere. Ethan Siegel. Love the guy. And what is Mr. Siegel saying? Well, he's saying that, science or physics, right? He's supposedly an astrophysicist, has to do with evidence, has to do with predictions, and has to do with confirmations, and that using these elements, they were able to prove, essentially, right, the expanding universe, the Big Bang, dark matter, dark energy, and inflation. They've proven everything. And what are these? What is the expanding universe? Is the universe a physical object? Is that what he's saying? Can he draw the universe? Can he make a picture of the universe? And if he does, what's he going to put on the outside of it? What is it pushing against? And that's when they, turned around and say, well, it's an unscientific question because we don't know what's outside the universe and there's no way of testing it. This is not a question of testing. This is a conceptual issue. There's nothing to test there. And then the Big Bang, same thing. Was there an origin to the universe? And the way they get around that is they say, well, we don't know what happened at the exact moment of the Big Bang or before. We can only tell you from the Big Bang onwards. Essentially, these people are trying to elude the question of the origin of the universe. They're telling you, look, it's unscientific to say what came before Big Bang because there was something. There was nothing. And what is nothing? Well, it's energy. And what is energy? Well, energy is, you have zero energy. It breaks up into positive and negative energy. And once you break those two up, one ends up as being matter and the other one is gravitation. That's how they explain these things. So they have a universe from nothing, as Mr. What's his name? I forget his name. Larry Krauss, as he says in his book, A Universe from Nothing. And that's how they produce something from nothing. Again, a lot of hocus pocus, a lot of witchcraft, and no understanding. Dark matter, I just covered. Dark energy, well, nobody knows what that is because they had to put that fudge factor in there, which is actually a measure of how much they don't know of their ignorance. And then inflation is something that was invented by Alan Guth. He came up with this nonsense that after God created the universe, it had a rapid rate of inflation, something that has nothing to do with nothing, with physics or science. So none of what Mr. Siegel vouches for has any relevance in physics or in science. The way if he wants to do science, he's going to have to, especially physics, he's going to have to put some objects in there, show us some mechanism. He has to show us how light works. And for sure, he's not going to be able to explain with particles, with a flow of particles. There are too many experiments that debunk the particle hypothesis, among them, the slit experiment. Not to mention polarization. You can't explain polarization with particles unless you do some hocus pocus voodoo. And in the case of the slit experiment, they had to invent decoherence. What is decoherence? Well, in very few words, a particle can be at two places at once. And, we're not talking about the particle splitting in half. We're talking about the same rabbit being at two places at once. And this is the explanation they give you. You're supposed to believe that? Well, forget about believing. Do you understand it? I mean, Hollywood can make the movie, make, a bunny rabbit in two places at once. Maybe, Bugs Bunny. You can't do that with physics in the real world of physics. Anyways, that's a wrap for today. And just to let you know that, we got a problem with official physics, official mathematical physics, which is not really physics. And these people are simply spinning their wheels, and they're going to keep doing it. In fact, I've got a little picture that I took out. Where is it? If I can find it, here it is. This is Scientific American, the same one that published Mr. Bjorn's article, which surprised me that they would publish it, but they did. And this is what you see in their literature, in Scientific American. What do they talk about? Black holes. They just fill you with all this nonsense for weeks and months and years on end. Multiverse, naked singularities. This is not science. This is just an attempt to sell magazines. That's all it is. What does this have to do with science? What do black holes have to do with science when they have not even defined the term black hole? We don't know what a black hole is, like I covered last week. You have the object and the concept. You have the two-dimensional hole that is the entrance to a wormhole leading to another universe. And you have the standalone three-dimensional ball, in which gravity flows to the center, to the singularity of that ball. So does gravity flow to other universes through wormholes, or does it fall to the singularity at the center of a ball? So, again, it's all surrealistic. It has no place in science. Mathematically, you can describe it. Yeah, you can do anything with math. Like we used to say in our engineering group, we used to say that we did it with with statistics. We say with statistics, you can prove that an elephant dances on a pin. And that's more or less the way it is. You can prove anything with math. because math is a logical system of proofs where one conclusion derives from the premises. That's got nothing to do with whether the premises are rational to begin with. We were discussing this today with someone, and you can say energy is equal to mass times velocity of light squared, right? Einstein's equation. Okay, you can start with these premises, and you can show that they're logically consistent. That doesn't mean that you are rational, or that your presentation, that the premise is rational, because they have never defined what energy is. And if you treat energy as a physical object, you'd be irrational. There is no physical standalone object called energy that you can point to. So the fact that it's logically consistent, that mathematics is logically consistent, it does not follow that those relations represent physical objects, or the ones that you imply that they represent specifically. That's where the problem comes. So logic, yeah. Rationality, that's a separate issue. Okay, well, we'll see you again on Sunday, and hopefully we can continue with what I started about a month ago, or a little over a month ago, which is the ether, and whether ether is space, and whether space, ether, or whatever is infinite. And that's a long story, because it involves a lot of generations from the Greeks onwards. We'll see you on Sunday. We'll see you then. Bye-bye.